Okay, we're going to see the second unit, the syntax in NLP. In the first unit, we have seen what is morphology and how we can understand the morphological analysis, what are the challenges, and what are the different morphological models we have seen. So, as we know that every language, whether it is natural language or whatever language it is, formal language, every language will have certain grammar rules. So what is a grammar? Grammar is the set of rules which will uh, make a sentence valid. For example, in English, we have a sentence, John eats an apple. Here, John is the subject and eats is an verb. Apple is an object. So the rule here is subject should be followed by the verb followed by the object. We cannot reverse this. You cannot write apple eats John. We cannot write that, or eats John an apple. We cannot write that because it is against the grammar. Then uh, once we know what is grammar, let us see what is syntax. Syntax says when a sentence follows grammar, we say that it follows the syntax. So syntax is a synonym for the grammar. We can understand like that. And syntax, if a sentence follows the given grammar, we say that it is syntactically correct. For example, in Python, print hello in double quotes is correct syntax, but if you omit those brackets or parentheses, then it is not correct syntactically in Python. Similarly, in C language, after print or scanf, if you put semicolon, it is syntactically correct, but if you don't put a semicolon, then it is syntactically wrong. So, grammar, whether it is followed or not, is verified by whether it is syntactically correct or not. Now, coming to the parsing, parsing is the process of analyzing a sentence to check whether it follows the grammar or syntax. So, if it is syntactically correct or not, that process is known as parsing. Parsing, what it will do is it will break down a given string or a sentence into meaningful component, and it will convert the given input into a parse tree, and it will analyze it. Generally, any component, any grammar will contain the following things. One is non-terminal, which can be extended or expanded further. These are abstract symbols, maybe sentence, noun phrase, verb phrase, propositional phrase. These are which can be expanded further are known as non-terminals. Then we have terminals, which are the endpoints. We cannot expand them or extend them further. The names cat, chases, all these are non-terminals. And the rules are known as production rules. For example, sentence is formed by noun phrase followed by the verb phrase. This is a rule. We call it as production rule. And every grammar starts with a starting symbol S, and it represents a sentence. So these four are the essential components of a grammar. Coming to the categorization of grammars, Noam Chomsky, the father of the linguistics, has classified the grammars into four categories. Unrestricted grammar, that is known as type 0, context sensitive grammar, that is known as type 1 grammar, context free grammar, which is known as type 2 grammar, and regular grammar, which is type 3 grammar. Now, coming to the unrestricted grammar, You can have any number of terminals or non-terminals on either side of either left-hand side or right-hand side. There are no restrictions or production rules. That means in the left-hand side you can have any number of terminals, and the right-hand side you can have any number of terminals. So it leads to infinite number of rules, and explaining them or evaluating them is cannot be done by manual or any other thing. We require Turing missions for that. So there is no restrictions on how many number of terminals and non-terminals should be there on the left hand side and right hand side. This is very powerful grammar, but computationally very expensive. The second one is type 1 grammar, which is also known as context sensitive grammar. So in this grammar, the left hand side can contain multiple number of symbols, but the number of non-terminals in the left hand side should be less than the number of terminals in the right hand side. That means the right hand side must be at least as long as the left hand side. For example, if you see the first rule, AB is forming ACB. So here the left hand side we have two non-terminals, and the right hand side we have three non-terminals. So this is valid context sensitive grammar. Why it is called context sensitive? Because if I want to for example, see this grammar here, alpha A beta is equivalent to alpha gamma beta. Now, because A can be substituted by gamma if A is surrounded by alpha and beta. That means it is context. A can be substituted by gamma only when A is surrounded by alpha and beta. If it is individually, I cannot substitute. So this is called context sensitive, because the substitution of A by gamma depends on the neighbors, on the context alpha and beta. This is known as context sensitive grammar. Then context free grammar is a grammar where left hand side can have only one non-terminal. So there we are putting more restrictions on the grammar. In the unrestricted grammar, there are no restrictions. In context sensitive grammar, the terminals on the left hand side should be less than or equal to the non-terminals in the right hand side. Now in the context free grammar, the left hand side can have only one non-terminal, not more than that. So when it is only one non-terminal, there is no context, there are no neighbors. So you can directly substitute anywhere without any context. So this is called context free because FHS of a production rule contains only one non-terminal. So for example, here E, left hand side only one non-terminal, left hand side only one non-terminal, one non-terminal. This is known as context free grammar. So for natural language processing, we'll be using the context free grammar. So this is the example of context free grammar, and we can substitute those grammar symbols and we can derive a sentence. For example, if you see the grammar, sentence is formed by noun phrase followed by verb phrase. Noun phrase is determiner like the, a, and noun or a noun. Verb phrase is verb followed by noun phrase, determiner the, noun cat or dog, verb chases. So what we can do is we can write a sentence. The dog chases cat. So this is an example of context-free grammar. In context-free grammar, we should be able to identify the POS tags. So these are the extensive list of POS tags: noun, singular noun, NN, plural noun, NS, so on and so forth, preposition nouns, verb, verb past tense, present participle, past participle, present non-third person, present third person singular is given by VBZ, then adjective, adverb, determiners, predeterminer, and WH determiner, which, whatever, preposition, conjunction, modal verbs, particles, interjunction, and WH words, who, what, whom. So these are the important POS tags used in parsing. So you know that parsing is very, very important in machine translation, question answering, information extraction, even in sentiment analysis, because in sentiment analysis also you have to understand the meaning of the sentence. So generally in every sentence to understand, we can write the sentence in predicate argument structure. Predicate is the verb or the key. So predicate argument structure, if you take an example of Simonesh gave Hemant a book, here the predicate is gave. That is a root word. So who gave? Simonesh. And who received it? Hemant. What was given? A book. So if we analyze what is the verb or the predicate, we can understand how the different words are related to each other in context of a predicate. So syntactic analysis or parsing is analyzing whether given sentence is valid according to the given grammar. So the input is the grammar and the sentence, output is the parse tree, and we will say whether this is following the grammar or not. So we can do the syntax analysis at the basic level or advanced level. At the basic level, just we can have the POS tagging, parts of speech tagging. For example, the quick brown fox jumps over lazy dog. So each word can be attached with POS, tagged with POS, the determiner, quick, it is adjective, brown is adjective, then fox, noun, jumps, third persons, singular, jumps, VBZ, like that. So this is the basic level tag. At the advanced level, we can have the full tree, parse tree. So remember, again, we'll come back to it. Parsing is generally done by two different ways. One is known as constituency parsing or phrase structure tree, where we'll be breaking the sentence into different phrases. Whereas in dependency parsing, we select a root word and we identify how the remaining words are connected to the root word. That is known as dependency parsing. Good, parsing is very useful, but there are certain challenges to parsing, especially in the natural language. That is known as ambiguity. Every language, especially natural languages, are unavoidably include ambiguity. We can give a number of examples, but let us take one simple example. The boy saw the man with a telescope. What is the ambiguity here? The boy saw the man with a telescope. Whether that boy has the telescope or that boy saw the man with telescope. That is the problem here. So this is known as ambiguity. Ambiguity may be resulting because of lexical. For example, every word will have different meanings. That's what we have seen in morphology. Bank, on one hand, bank means financial institution. On other hand, it means the river bank. Light, it may be electrical light or lightweight baggage or weight. So that is known as lexical ambiguity. Just now what we have seen is structural ambiguity. Then there is another ambiguity called attachment ambiguity. For example, you say old man and woman. This word refers to only men or both men and women. Dear boys and girls, when I say that, this dear applies to only boys or girls also. So parsing algorithm should be able to resolve this thing, resolve this ambiguity. Now, if you see, for example, text-to-speech system. Let us say there is a sentence. We write, when we write, we can use drive in, but when we speak, we say he wanted to go for a drive-in movie or drive in the country. Drive-in movie means where the people will come in a vehicle and see the movie. So when we write, we can differentiate it. But even when we speak, we should be able to distinguish between those two sentences, ambiguity. Here, if you see another challenge here, the cat who lives dangerously had 9 lives. Here, the first lives is verb, and the second lives is a noun. So the parser should be able to identify which one is noun and which one is verb. So parsing, even in text summarization also, which one can be removed? For example, here there is a sentence: beyond the basic level, the operations of the three products vary widely. Here we can remove beyond the basic level, very widely we can remove, and three cardinal number we can remove, and simply we can write the operations of products vary. So it should be able to understand what can be removed in text summarization. This is another challenge. So we know that parsing has many applications in machine translation, information extraction, text summarization, speech recognition, language summarization, error correction in the text, dialogue system, knowledge acquisition, text to speech systems. So what is the requirement parsing? For parsing, we need a grammar, a context-free grammar. There is a manual or there is a standard with which a given sentence is compared. So every context-free grammar, as I already told you, it forms with 4 things: non-terminal, which can be expanded further, and terminal, which are the endpoints, words in the language, production rules, or the rules how the non-terminals we can expand them, and sentence symbol, starting symbol. Now here, take an example of context-free grammar. Sentence formed by noun phrase and verb phrase. Noun phrase is John pockets, or a determiner noun, or noun phrase followed by preposition phrase. Verb phrase is verb followed by noun phrase, and verb phrase followed by prepositional phrase. Verb is bought, determiner is a, then noun is a shirt, preposition phrase is preposition followed by noun phrase, and preposition is with. The sentence here is John bought a shirt with pockets. Here we have a grammar, but still we have ambiguity, because this sentence has 2 meanings. In one meaning, John bought a shirt with pockets. That means with the money in his own pockets. This is the first parse trick. Another interpretation is John bought a shirt with pockets. Shirt with pockets is a noun. So this is more plausible one. That means to understand correct parsing, the parser should have knowledge. That's why it is called knowledge acquisition problem. And not only that, when we have different rules, they can combine with each other and they can form number of rules in exponential way. For example, if you see one grammar here, noun is formed by noun and noun. That noun is natural language processing book. So the sentence is natural language processing book. So what is the ambiguity here? Suppose if you combine natural language, then natural language is a single noun, processing of that natural language. That is the correct interpretation. But another way interpretation, language processing is a concept, natural way of doing language processing. Of course, that is not correct, but that is not correct we are saying because we have that knowledge. So parser should have knowledge. So when we have n number of words, the number of parse trees that can be formed by given n words is given by catalan number 2n factorial by n plus 1 factorial into n factorial. If you have 3 words, we can form 5 possible parse trees. If you have 5 words, we can form 42 possible parse trees. With 6 words, there are 132 possible parse trees. So there is another problem. This another problem number 2 is that when we have options, different options of parse trees, which one has to be chosen? First one is to understand the grammar, we need knowledge. And number 2, we need to know which parse tree is the correct one, which one is most accepted one. So the solution to this problem, these two problems are tree banks. What are the tree banks? Tree banks are collection of sentences which have manual annotations, explanation for each sentence, which one is correct. So this is a mammoth task, but still language scientists have developed this one. Manually, they have taken each sentence and they have given annotation for that. In traditional grammar, we have the rules, but in tree bank, we have sentence followed by the explanation. So in traditional grammar, we should know the rules and we have to apply the rules to that. But whereas in tree banks, we don't have rules. We don't explicitly give rules. We give sentences and explanation. Can we find all the sentences? No. But what we can do, we can have a machine learning technique to apply the rules which are apply the annotation which is there and apply that similar annotation to the input sentences which we give. So there are different types of popular tree banks. One is known as pen tree bank, which is based on phrase structure graphs, universal dependencies based on dependency graphs. Tree banks are formed by phrase structure trees or dependency graphs. We'll continue this in the next class. Thank you.